Okay, let's look at a couple more examples of extrema functions of two variables. I've got the following question. Find all local extrema of f of xy is x squared plus 4xy plus y squared minus 6x plus 1. The gradient of f is 2x plus 4y, and 4x plus 2y minus 6. I'm going to set that equal to what? The zero vector in order to find the stationary points. Okay, and you can see I've got two equations and two unknowns. 2x plus 4y equals 0. 4x plus 2y minus 6 is equal to 0. You can solve that using Gaussian elimination or whatever technique you like here. I ended up getting y equals -1 and x equals 2. So the point, the stationary point that we're looking at here has coordinates 2, -1. Okay? Now what are we going to do next? We're going to go ahead and compute the determinant of the Hessian here. So we'll just call that D. F sub xx, f sub xy, f sub yx, f sub yy. Okay? Let's come up here. This should be really easy in cases like this. So f sub xx would be what? 2. F sub xy would be 4. F sub yx would be 4. And f sub yy would be 2, wouldn't it? So there, okay, that's exactly what I have there. Find that determinant. Okay, so that would be 2 times 2 minus 4 times 4. So that would be -12. Since that's a negative number, this indicates what happens is that the second partial derivatives will change sign depending upon which direction you go here. You will get sign changes. This indicates that it's a saddle point at 2, -1. So it's concave up in certain directions and concave down in other directions. So, a surface like that. Okay. Righty, there's not going to be any extrema then that we've seen, because this is what? The only single stationary point that we've got. Okay. Just by the way, in other cases we may have multiple stationary points. Okay? All right. Well, I hope you understood that example. That's pretty simple. We'll do another one here real quick. Let's take a look at a second problem here. Find the stationary points of z equals f of xy is 1/3 x cubed plus x squared y minus y squared plus x plus 2y plus 12. Classify the various stationary points. Okay? What we need to do, is what? Got to find the stationary points by finding the gradient of little f here and setting it equal to the zero vector. Okay? Now, f sub x turns out to be x squared plus 2xy plus 1. F sub y ends up being x squared minus 2y plus 2. Okay? And we're setting those both equal to 0, and we need to solve this system of two equations in two unknowns. Okay? Well, there's various techniques we might use here, but what I'm going to do, I tell you what I did, was go ahead and graph each of these on Desmos. I hope you know how to do that. If you don't, I might show you sometime. But graph each of those on Desmos, and then what? Find the points of intersection. It's very easy to do. It will do it for you. Just find where the curves cross and click on those points and get some, zoom in a little bit and get a few decimal places. I think it only goes to like 4 decimal places on Desmos, though, unfortunately. Okay? You could go other places and solve these with Wolfram or something like that, but we could actually probably do it ourselves here as well. But this is what I chose to do. You want to be able to understand how to use some systems like that, like Desmos, because when it comes to the exam, I will be giving you some problems where you might need to actually use something like that to get the stationary points. I don't always give problems where the problem's set up just so it's so easy for you. Okay, this is more realistic in the real world, when engineers and scientists solve questions like this, they're not always set up just to make it easy for you. Okay? But the next step would be to what? Take each of these derivatives and differentiate them. And we end up getting what? Second partial with respect to x, 2x plus 2y. F sub xy is 2x. F sub yx is also 2x. F sub yy just ends up being negative 2. Okay, you can see that there. Okay, actually compute that determinant and you get the following. Negative 4 times x squared plus 4x plus y ultimately. Okay, there I've written it in a nice form. Now what you want to do is take that and do what with it? You want to evaluate it at the stationary point. So you want to come up here and put these values into this formula right there and see what kind of value you get out. You get what? A negative value. What does that mean? That means it's a saddle point. Okay? Alrighty? So there's a couple examples there. The test is fairly easy to use. And this, I gave you this example to show you that you could use some technology involved here to make your life just a little bit easier. Okay? All right. Well, I hope you understood this.